Stages of a star's life cycle. A star's life begins in a nebula, a cloud of gas and dust consisting mostly of hydrogen. Gas and dust begin to clump together to form a protostar, which is a baby star. Life cycle of a star like our Sun. Nebula, then protostar, then main sequence star. After that the red giant, then planetary nebula, then the white dwarf. Life cycle of a star like our Sun. Our Sun is at the main sequence stage in its life. When the hydrogen in the core has been used up, the core shrinks and hydrogen fusion begins in the outer layers, which then expands the entire star, turning it into a red giant. The Sun begins to die when helium is fusing into other elements. Then the gases at the Sun's surface start to blow away and burst, called the planetary nebula or a halo of gases, resulting in a hot carbon-oxygen core called the white dwarf. Life cycle of a star with greater mass than our Sun. Nebula, then protostar, then main sequence star, then red supergiant, then supernova. Supernovas consist of black hole or neutron star. Life cycle of a star with greater mass than our Sun. Massive stars go through the same life stages as our Sun, just on a larger scale, up to the main sequence stage. Then the massive stars expand into the red supergiant, explode into supernova, then turn into a black hole or neutron star. This is a picture for the life cycle of stars, and this for the HR diagram. The HR diagram. HR diagram is a tool that shows relationships and differences between stars, temperatures, brightness, and colors. It is something of a family portrait. It shows stars of different ages and in different stages, all at the same time. A star in the upper left corner of the diagram would be hot and bright. A star in the upper right corner of the diagram would be cool and bright. The Sun rests approximately in the middle of the diagram, and it is the star which we use for comparison. A star in the lower left corner of the diagram would be hot, and the star in the lower right corner of the diagram would be cold. This is a picture for the diagram. Something we have to know that the larger a star, the brighter the star is. A video about the stages of a star's life cycle.
It's estimated that there are 300 billion stars in the Milky Way galaxy alone, which gets pretty terrifying when you consider that there are billions of galaxies in the universe. Each star has a different set of planets, rocks, and even other stars orbiting it, and each star has a different life. However, we know the basic life cycle of a star, and it's different depending on if it's a low-mass star or a high-mass star, but each one starts out the same, in a nebula. In this video, we will cover the life cycle of a low-mass star. The star begins just as we discussed in my last video. The nebula spins and spins and creates a center mass, but before the hydrogen starts burning, it's known as a protostar, or a baby star. The protostar will stay in this stage for anywhere between 10 and 100,000 million years, depending on the size of the star. Once the hydrogen begins to fuse helium, it becomes a main sequence star. A star will live most of its life as a main sequence star. In fact, about 90% of known stars are main sequence. Our very own Sun is a main sequence star, and for our sake, let's hope it stays that way for a long time, because in about 5 billion years, a main sequence star will begin to burn its helium. And when the main sequence is all out of hydrogen to burn, it becomes a red giant. A red giant is exactly what it sounds like, red and giant. It burns red because its outside layer has a lower temperature, around 5,000 Kelvin, whereas a main sequence star could burn as hot as 40,000 Kelvin. As for the giant, our Sun will slowly get bigger and bigger as it burns helium. It will absorb Mercury and Venus and scorch the surface of the Earth, making it uninhabitable. Yikes. After about 10 billion years, the red giant will become unstable and its core will no longer be able to hold the outer shells of the star. The outer shells will separate from the core of the star and create what is known as a planetary nebula. In the center, there remains a white dwarf star. After a few thousand years, the planetary nebula will dissipate and be recycled into another nebula to restart the process. However, the white dwarf star remains. The white dwarf will burn for billions of years until it eventually cools and becomes a black dwarf, emitting no light or energy. At least that's the theory. Scientists do not know 100% of the black dwarf star because we have never discovered one, but it is the most plausible guess given what we know. And that is the simplified life cycle of a low mass star. Thank you guys so much